The last part to build here is the Pear cam, and this cam is very similar to a part that we'll build for the Automata project, although the dimension of the axle and sizes are a little different. You can vary. But this is also going to introduce some new tools. One thing to notice here, we have a 1.25 inch radius at the bottom and a 0.5 inch radius at the top. And there's more than one way to do this, but introducing a few new tools will kind of pay attention to that. So I've got a part already started and named as Pear cam. I'm going to start a sketch on the XY plane. The most important part of a cam would be where it's going to rotate about. So I want to make sure that I use that center point this time as the origin. So I'm going to, instead of selecting an arc tool, I'm going to select a circle tool. So I'm just going to draw a circle tool at the origin, and you'll notice that by default you see the line going all the way across. A circle gets dimensioned by its diameter, an arc by its radius. So Inventor loves math. Not that you would have to do this, but I could do 1.25 would be the radius. And then put in times 2. Now I'm not insulting your intelligence for saying, hey, like you can't multiply 1 1/4 times 2 to get 2.5 inch diameter because we had a radius of 1 1/4. But Inventor will do that, and if it is much simpler, a lot of times your students would struggle with that. I want to use the circle tool again, and I'm going to purposely sketch this second circle not centered above the origin there. So I purposely drew it off that axis, 1 inch diameter. And we see we have a lot of dimensions needed. So what I'm going to do this time, to get that lined up, I'm going to use the vertical constraint to line up the point with the origin point, the center point of the second circle with the origin, which is also the center of the first circle. And you'll notice that lines it vertically up. It magically jumps over there. The distance between those two is 1.75 inches. So we'll go ahead and add that constraint. And interestingly enough, that distance also made those two circles tangent to each other, although they wouldn't have to be. In order to get the pear shape, I'm going to come over here, and I'm just going to arbitrarily draw 2 lines connecting the 2 circles. When I do that, then I want to go back and add a tangent constraint, which will make that line tangent to the curve. So I'm going to select the line and the circle, and the line and the circle, and now you'll see that the tangent constraint has gone away, or the blue line, the tangent's there, but now been applied, and the blue line showing that it's not fully constrained has now disappeared. I'll do the same thing to the other side, and it doesn't matter which object you select first. Finally, this gives us a lot of oversecting profiles. So if I would try to extrude that shape, I have a lot of different profiles, and I could select different ones. But if you have one single profile, it's often best to extrude one single profile. By the way, to get back into that sketch, I don't want to create a new sketch. You'll often see beginners do this. They'll start a new sketch, and now there's 2 sketches there, and now they can't even change, they can't modify things or get things to line up. So we want to work with, for most features, 1 sketch at a time. So all I'm going to do is go in and edit the previous sketch. So the best practice really is, especially when you have intersecting lines like this, would be to have a single profile. So I'm going to go ahead and trim off, using the trim tool, the excess lines that are not needed. So now I can extrude and select one single shape that doesn't intersect with each other much easier. Distance to extrude it is 1/8 of an inch. Okay, and then we need a square hole in the middle for the axle. So I'll select the sketch. You'll notice that it automatically projected the center point of the origin, so that can be helpful. To get the square, I could draw a rectangle, but the easiest way to do this would be to draw a polygon. And you see there's multiple ways you can do a polygon, inscribed or circumscribed. But let's change the polygon to have 4 sides, and then select the origin and draw a square. Now you notice I drew that crooked. I did that on purpose. Let's go ahead and use the horizontal constraint to square up the square, so it's now perpendicular to the circles of the Pear cam along their minor and major axes. And then we can dimension with one dimension that hole is 0.125 inches for a square hole through the middle of that Pear cam. So then we'll finish the sketch and do a cut extrusion. And best practice is always to cut all. And then the final thing that this has you look at is looking at the eye properties. So if I go into eye properties and go to the physical tab on the eye properties and select update using a generic material, if you have modeled that part correctly, your mass of 0.021 pounds, 13.588 inches, volume of 0.722 inches would be the mass, area, and volume. So Inventor can be invaluable not only as a design tool, but it gives us physical properties for the part. In addition to that, we could find center of gravity and moments of inertia and all kinds of fun stuff. But the primary one we use is mass, area, and volume. And that's the last part for 4.2.